Good morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about problem solving on design of common bus system. So before going to common bus system, we are discussing about bus and memory transfer. A more efficient scheme for transferring information between registers in a multiple register configuration is a common bus system. A common bus consists of a set of common lines, one for each bit of a register. Control signals determine which register is selected by the bus during each particular register transfer. So there are different ways to constructing a common bus system using multiplexer, using tri-state buffer. So what is a common bus system? When we are transferring the data from one source to another, or from one file to another, or one memory to another, so we need a common bus system. So what are the how we are constructing the common bus and what we need? So majorly we need multiplexer and tri-state buffer to transfer the data through the bus system. So a more efficient scheme for transferring information between the registers in a multiple register configuration. Suppose in the R1 register I have the data, I am copying or I am sending the data to the R2 register. So how we are transferring the data from R1 to R2? Through the bus system only it is possible. So how we are transferring? So what is the way to transfer? And it is a common bus system. So it is called a common bus system. So through the bus only it is possible from one register to another register. So through the bus means we are taking as a common bus system or common lines to transfer from one register to another register. So one for each bit of a register. Control signals determine which register is selected by the bus during each particular register transfer. So when we are transferring the data from R1 to R2, it is called register transfer. Register transfer data. So control signal will monitor. Control signal will monitor data, registers, and bus system. So control signals will monitor what is the data is transferring and what are the registers we need from transferring from one register to another register, and how what is a bus system. Here I am using multiple register configuration. So how we are sending the bus system? It is a common bus system. So common bus system means which type of bus you are using and how many are completed, how much data is pending now. So till like this data. So there are different ways of constructing a common bus system using multiplexer, using tri-state buffer. So these are the methods to send the data through the registers. So these are the methods to send the data through the registers. So if I'm using multiplexer, how the bus system is using, and if I'm using tri-state buffer, how the data is converting in the common bus system. Multiplexers, tri-state buffer. So when R1 to R2, the data is sending common bus system. So in the common bus system, how multiplexers are designing, how the tri-state buffers are designing to sending the data from one register to another register. Common bus system using multiplexers. The multiplexer select the source register whose binary information is then placed on the bus. It is constructed with the help of 4 into 1 multiplexers, each having 4 data inputs 0 to 3 and 2 selection lines, that is S0 and S1. So when I'm using multiplexer, So it is also called mux. Multiplexer also called mux. So multiplexer means number of inputs, one output. So you can take number of inputs, but we will get only one output. That is a multiplexer. So suppose I am taking n number of inputs. So 2 power n. That means 2 power 0, 2 power 1, 2 square, 2 cube, like this. So here I am taking 4 into 1. That means 2 square. So 4 is to 1 multiplexer. So when I am using 4 is to 1 means 4 inputs, 1 output. That is called 4 is to 1. So inputs are 4 and output equal to 1. So 4 inputs, 1 output. Multiplexer means n number of inputs, only 1 output. That is called a multiplexer. So here multiplexer select the source register whose binary information is then placed on the bus, and it is constructed with the help of 4 is to 1. Here 4 is to 1 is one example. Here we are taking, it is one example. So in this example, I am taking 4 is to 1 means 4 inputs and 1 output, and each having 4 data inputs, that is from 0 to 3, 0, 1, 2, 3. So how many are there? Total 4 inputs. The 4 inputs I am taking as a 0 through 3. That means 0, 1, 2, 3. And 2 selection lines, S0 and S1. Why? Because 2 square here, 2 square equal to 4. So 4 input lines are there. 2 square means how many selection lines are there? 2 selection lines. So when I am going for the 2 square equal to 4, these are the 4 input lines. This query is called S0 and S1. So these are called selection lines. Suppose if I am taking 8 is to 1, 8 is to 1, that called 2 cube equal to 8. Cube equal to 3 means 3 switches, S0, S1 and S2 selection lines. So here example I am taking one example. Construct a bus system for 4 registers using 4 is to 1 multiplexer. So I need to transfer the data through the registers. Here one example is there. Construct a bus system. Bus system is using for transferring the data. Transfer data. So bus system is nothing but we are transferring the data through the bus. That is a bus system. So this 4 is to 1. We are sending 4 is to 1 means we are sending the data through this one, and 4 is to 1 multiplexer. Here the bus system is transferring the data through one register to another register. But how many I need here means 4 registers. I am taking 4 registers, but how many outputs are there? One selection line. So one output is there. 4 is to 1 multiplexer. So how we are designing through the multiplexer? So it is a bus system through the multiplexer. Mux means multiplexer. Here using multiplexer, how we are designing a bus system. Answer. How many selection lines here? See here, 4. 4 input lines, 1 output line. So 4 inputs, 1 output. 2 square. So square means how many selection lines are there? S1, S0. So 2 selection lines. That is called 2 square equal to 4 is to 1 multiplexer. So S0 and S1 are the 2 selection lines, and 4 registers are there, and only 1 output we are getting. So 4 is to 1 marks. Here multiplexer 1, multiplexer 2, multiplexer 3, multiplexer 4. That is called mux 0, mux 1, mux 2 and mux 3. So 4 into 1. So how many inputs are there now? Here 4 input lines are there. 4 input lines are there, only 1 output. Here, how many inputs are there? 4 input lines are there, only 1 output. 4 input lines, only 1 output. 4 input lines, only 1 output. So 4 is to 1 means I am giving 4 inputs, only 1 output. So total how many are there? For this one output, one output, one output, output. So it is a 4-line common bus system. So at a time in the bus system, it is a common bus system. How many are there? Common bus with 4 line. So here 4 line common bus system, that is called MUX 3, MUX 2, MUX 1 and MUX 0. How many are there here? I am taking 4 multiplexers, that is a 4 is to 1, 1, 2, 3, 4. 4 is to 1. It is one output line, it is another output line, another output line, it is another output line. So total how many are there means 4 line common bus system, 4 line common bus system. So how many inputs are there? Total 4 inputs. Here also 4 inputs. 4 inputs. So what are the input lines means? Here I am taking A0, A1, A2, A3. So A0, B0, C0, D0. So A0, here B0, B1, B2, B3. C0, C1, C2, C3. D0, D1, D2, D3. How many are there? Total 4. So here register A, register B, register C and register D. So how many registers are there? Here I am taking 4 registers with 1 output line. So 4 line output with 4 registers. So how many are there? Here 4 input lines. 4, 4, 4, 4. How many are there? 16 is to 4. That is 4 is to 1. So here this register has a 4 bit, 4 bit, 4 bit and 4 bit. So register 4 registers I am taking. Each register one line is supporting to the 1 mux. So every mux is taking 4 input lines and 1 output line. 4 input lines, 1 output line. Total how many are there? 16 input lines and 4 output lines. That is a 4 is to 1. When I am taking S0 and S1. If S0 is there, what about the switch lines? If S1 is there, what about the switch? We will discuss later. And the 2 selection lines S1 and S0, that means 2 selection lines S1 and S0. So if S0 is there in the mux, what will happen? If X1 is there, what is the mux will happen? We will discuss. And the selection lines choose the 4 bits, 1 register and transfer them into 4 line common bus. When both of the select lines are at a low logic, that is S0, S1 equal to 0, 0. The 0 data of all 4 multiplexers and selected and applied to the outputs that forms the bus. So each selection line S0 I am taking S1. So if I am taking S1 and S0, 0, 0. If I am taking S0 equal to 0, S1 equal to 0. So that means 0, 0. It is a 0. 0 data of inputs of 4 multiplexer selected line at the output, that format bus. Okay. S0 0, 0, 0, 1, 1, 0, 1, 1. Okay, like this. How many selection lines are there? Now 4 selection lines are there. Why? Because 2 square equal to 4 selection lines. Only one output, like this. So the bus lines to receive the content of register A and the outputs of these registers are connected to the 0 data inputs of multiplexers. Similarly, S0, S1 equal to 0, 1, register B selected, and the bus lines will be receive the content provided by the register. Previously, I am taking S1, S0, 0, 0, A register will be selected. Here, S1, S0 equal to 0, 1, register B will be selected. Already we know that how many registers we have here? 4 registers. That is the register A, register B, register C, register D. So it is the S0, S1, 0, 0, register A, S0, S1, 0, 1, register B will be selected, and the bus lines will be receive the content provided by the register B. 0, 0, 0, 1, 1, 0, 1, 1. Register A, register B, register C, and register D will be selected. So the following functions of the lines of the register is selected by the bus of each of the 4 possibilities of that one. So S0 equal to 0, S1 equal to 0, 0, 0, register E will be selected. 0, 1, register B will be selected. 1, 0, register C will be selected. 1, 1, register D will be selected. 0, 0, 0, 1, 1, 0, 1, 1. A register, B register, C register and D register. Why? Because here 2 square equal to 4. So 4 registers I am taking. So 2 square equal to 4 possibilities are there. So why I am taking 2 square means here 2 selection lines. 2 square equal to 2 selected lines and 4 possibilities, or 4 registers I am taking here as input and 1 output. So it is the table below register that is selected by the bus of each of the 4 possibilities of binary values of the selection lines S0, S1, 00, 01, 10, 11, and register A, B, C, D. 00 means register A, 01 means register B, 10 means the register C, 11 means register D will be selected. So common bus system using tri-state buffer. Previously we discussed multiplexer or mux. Here I am taking 4:1 mux, 8:1 mux, 16:1 mux, or 2:1 mux, like this. So if I am taking 2 means 2 power 0 equal to 1, 2 power 1 equal to 2, 2 square equal to 4, 2 cube equal to 8, 2 square equal to 2 power 4 equal to 16. So 2 power 1 means 2. Here also 2. So how many selection lines? 1 selection line. Here 2 square equal to 4. If I am taking 4 means how many selection lines? 2 selection lines. 2 cube equal to 8:1 marks. How many selection lines? 3 selection lines. 2 power 4 equal to 16. So how many are there? 4 selection lines. 4 selection lines. So next one, common bus using tri-state buffer. The 3 state gates can be considered as a digital circuit that has 3 gates, 2 of which are signals equivalent to logic 1 and logic 0 as conventional gate. However, the third gate exhibits a high impedance state. The most commonly used 3-state gate in the case of bus system is a buffer gate. The graphical symbol of 3-state buffer gate can be represented as 3-state gate can be considered in the tri-state. Tri means 3, so 3-state gate. Tri means 3. So tri-state buffer means we are taking 3-state gates or 3-state buffer can be considered as a digital circuit, and 3 gates, 2 of which are signals equivalent to logic 1 and 0 as a conventional gate. However, the third gate exhibits a high impedance state. Third gate has high impedance gate. High impedance gate. The most commonly used 3-state gate is a bus system in a buffer gate. As a buffer gate. The graphical symbol of a 3-state buffer can be represented as normal input A, normal input C, and output is Y. How many are there here? 1, 2, 3. So it is called 3-state bus system. Tri-state buffer. 2 inputs and 1 output. So 2 plus 1 equal to 3. It is called 3-state buffer or tri-state. Normal input A, normal input C, and output is Y. So 2 inputs and 1 output. So example I am taking, construct a bus system with a 3-state buffer using decoder. In the previously we discussed and not encoder, like a multiplexer. Here I am using 3-state buffer using decoder. Example we are taking sometimes encoder also. So the outputs generated by the 4 buffers are connected to form a single bus line. Only one buffer can be in active state at a given point of time. The control inputs to the buffers determine which of the four normal inputs will communicate with the bus lines. A 2 into 4 decoder ensures that no more than one control input is active at any given point of time. So, construct a bus system with three-state buffer using decoder. In the previously, it is a three-state buffer. Here I am taking here using decoder. So, how decoder is constructed and what is the use if you are connecting to the decoder? That is that the outputs generated by the four buffer are can be to form a single bus. Here only three buffer, but here I am taking four buffer, and only one buffer can be active state at a given point. Only one buffer can be active, and the control inputs of the buffer determine which of the four normal inputs will communicate with the bus line. A 2 into 4 decoder, 2 into 4 means two inputs, four outputs. That is called 2 into 4 decoder. Ensures that no more that one control input is active at a given point of time. 2 into 4, two inputs, four outputs. So here 2 into 4 decoder, two selection lines. It is a enable or a disable. If enable equal to 1, if it is 0 means it is a disable. 2 into 4 means two inputs, that is S0, S1. So how many are there? Here four outputs are there. 1, 2, 3, 4. So it is 1, 2, 3 and 4. So these are connected to the input gate. So it is the output. It is the output of this one. It is the output of this one. It is the output of this one. So how many are there now? Enable. If enable equal to 0 means there is no inputs are there. If enable equal to 1 means that is enabled. So enable means it is enabled, means switch is on. Then how many possibilities are there now? So total how many possibilities are there now? Here two inputs are there now. So two possibilities, 2 square equal to 4 possibilities are there. That is 0 0 0 1 1 0 1 1. How many outputs are there? You can observe here. Select means S0 S1. So 2 square equal to 4 possibilities are there. 4 input possibilities. 4 input possibilities, that is 0 0 0 1 1 0 1 1. If I am taking 0 0, then it is y0 equal to 1, remaining all 0. If I am taking 0 1, that means y1 equal to 1, remaining all 0. If I am taking 1 0, y2 equal to 1, remaining all 0. If I am taking 1 1, y3 equal to 1, remaining all 0. So 0 0, y0 equal to 1, 0 1, y1 equal to 1, 1 0, y2 equal to 1, 1 1, y3 equal to 1, like this. So how many possibilities? 1 2 3 4 possibilities are there. So 4 outputs with inputs are 2 inputs, but how many possibilities are there means 4 possibilities are there. That is a 0 0 possibility, 0 1 possibility, 1 0 possibility, 1 1 possibility. So how many outputs means 4 outputs, that is 0 0 0 0 0 0 0 1 0 0 1 0 0 1 0 0 1 0 0. So these are the possibilities. Here I am taking one decoder, that is a 2 into 4 decoder. It is one example, and we are taking 4 possibilities of inputs, but only 2 inputs are possibilities and 4 outputs are there. Here bus line for bit is 0. Okay, when I am taking the bit 0, it is a bus line. And example 3, perform read and write operation in the standard. Notations used for specifying operations on memory transfer. Perform read and write operation in the standard notation used for specific operations on memory transfer. So I have to perform read and write operation. How you are building the gate, how we are preparing, how we are constructing the logic gate, that is important in the memory transfer. The transfer of information from a memory unit to the user ends is called read operation. The transfer of new information to be stored in the memory is called write operation. And a memory word is designed by the letter is M. So memory operation, that is called M. Memory transfer means one register of data is transferred to the R1 to R2 like this. So one memory to another memory. So memory 1 to memory 2. I have to transfer the data. So memory transfer. So it is through the bus only it is possible that it is the data is transferring from one memory to another memory. That is called memory transfer. So memory transfer, but is it read operation or write operation? So what is read operation and what is write operation? The transfer of information from memory to the user. Memory to the user. Suppose I am taking one system. So it is one user. Okay. User is giving the information. User is giving the information. Okay. Memory to user. That is called read operation. User to memory. That is called write operation. So memory to user, user to memory. That is the user is entering the information to the computer. To the computer. That is a write operation. The user is getting the information from the computer. That is called read operation. From the computer, read to the computer, write operation. And a memory word is designed by the letter M. So any of the memory transfer I'm discussing, we are taking the symbol is M. And we must specify the address of memory word while writing the memory transfer operations. The address register is designed by AR and the data register is DR. So R1 to R2, I have to transfer the data. So here R1 and R2 are the data registers, and address register means what is the address of this memory? Address of the memory. Here also, what is the address of this memory location? Address of memory location. A read operation can be stated as DR tends to M of AR. That means data register is what is the address, memory address. In this, what is the address of this memory? Suppose this is the M1 register, example M1 memory. So for this M1 memory, what is the address? What is the address of this memory? That is the address register. And what is the data? In this address, what is the data? What is data in this in the in this address? So in the particular memory, what is the address of this particular memory and what is the data is there in that particular memory? That is M of AR to DR. That is a read operation. Read statement causes the transfer of information into the data register DR from the memory selected by the address register. Okay, here I am performing the read operation. Already we discussed what is the read operation here now. What is the read means? Memory to user, memory to user, system to user. So like this, system to user. M of AR, I am going to a particular memory with a particular address, and in that particular address, I am getting the data from the address. That is a read operation. So the statement causes the transfer information into the data from the memory and selected the address register AR. And the corresponding write operation can be stated as M of AR tends to R1. So R1 tends to M of AR. It is a corresponding write operation can be stated. So in the R1 register, R1 register, in the R1 register, what is the address in the particular memory? What is the address of this register? So I have the data. I have the data in that R1 register, but what I'm seeing that it is the address. Sorry, it is the data of R1. But what is the address of this one? So it is defining the address of this data with a particular memory. That is called the write operation. Here address tends to DR. Here data tends to address. The write statement causes a transfer of information from register R1 into the memory word M. Selected address lines are AR. So here address line is defining it is going to the memory unit and it is defining what is the read and what is the write operation. And here data out and data in. So memory unit consists of address and data. So every memory unit we are consisting as address and data. So it is a data out and a data in. When it is going to the data in and when it is going to the data out, that is called, if I am going to the system, it is a memory, it is a user, memory to user, that is a read operation, and user to memory, that is a write operation. Okay, so it is called data out and it is called data in. So the user is entering the data to the system, that is a data in, that is a write operation. User is getting the data from the memory, that is the data out. So data out and data in. Data out means it is a read operation. Data in means it is a write operation. So data in means write operation for data. Data out means read operations performing to the data out. And what are the particular addresses for this memory? Okay, every memory have address. Okay, so the write statement calls us the transfer of information from register R1 into the memory word M, and selected address links are AR. These are the references about this one. So today we discussed in the common bus system, there are two types of common bus system, using multiplexer and using tri-state buffer. So in this one, common bus system is a transferring the data from one memory to one another memory, or one register to another register. So bus is transferring the information from one register to another through the address and data. But how we are constructing the registers, memory and bus? Okay, using multiplexer and using tri-state buffer. Okay, in the common bus system using multiplexer, a multiplexer select the source registers whose binary information is placed on the bus. Here I am using multiplexer to construct the bus system. Okay, so construct a bus system using 4:1 multiplexer, that is the 4 registers. 4:1 is nothing but 4 inputs, 1 output. Multiplexer is nothing but a mux. In number of inputs, only 1 output, that is called multiplexer. Here also I am taking 4 multiplexers, mux 0, mux 1, mux 2, mux 3. How many are there here? 4 mux. And how many output lines? Every multiplexer, 1 output line. That is a 4:1 multiplexer. And how many registers here? A0, A1, A2, A3. That is called register A. And B0, B1, B2, B3. Register B. C0, C1, C2, C3. Register C. D0, D1, D2, D3. Register D. So every register has the 4 bits with connecting to the multiplexer, and every multiplexer has one output. Totally 4 into 1 makes 4 line bus, common bus. And here how many selection lines are there means, here 2 selection lines, S0 and S1. So 2 square equal to 4 possibilities are there, that is 0, 0, 0, 1, 1, 0, 1, 1. 4 possibilities of there, that is the 2 selection lines. And every selection line, what will happen? The select line of 4 registers and transfer them into the 4-line bus system. And when the both selector lines are S0, S1, 0, 0, the 0 data inputs of 4 multiplexer can be applied to the outputs of the bus system. And here, when I am taking S0, S1 equal to 0, 1, register B selects the bus lines will receive the content provided by the register B, and bus lines to receive the content of register A, and the output of register connected to the 0 and data inputs of the multiplexers. Here S0 S1 0, 0 register A, S0 S1 0, 1 register B, S0 S1 1, 0 register C, S0 S1 1, 1 register D. So how many registers are there? Total 4 registers are connected with the 2 selection lines. 2 square equal to 4, 2 selected lines. 4 possibilities of inputs. 0, 0, 0, 1, 1, 0, 1, 1. So 4 possibilities are there, A, B, C, D. Here common bus system using tri-state. Tri-state means 3-state buffer. Okay, 3 states are there. So when I'm using three-state buffer, that is also called buffer gate. And the graphical symbol of three-state buffer we can represent as like this: normal input, output. Two inputs, one output. Total three logic gates, three gates. That is a three buffer. One logic gate with three lines are there. So three buffer means three line. Three-state buffer, that means three line. Example: construct a bus system with a three-state buffer using decoder. Okay, here I'm taking three-state buffer, but I'm applying here decoder. Decoder means 2:4 like this. So if I'm taking 2 power n and n output lines, 2 power n and n output lines here, n is to 2 power n. So if I'm taking n equal to 2 means 2:2 square means 4. So 2:4. Here I'm taking n equal to 3. That is n equal to 3. 2 cube equal to 8. That is 3:8. Here I'm taking example 2 into 4 decoder. 2 into 4 means n is to 2 power n. So decoder using one control input activate at a given point of time. Here I am taking 2 into 4 decoder. That is the two selection lines and one enable state. Enable and disable. If it equal to 1, enable. If it is equal to 0 means disable. Here enable equal to 1, 0, 0. Enable equal to 1, 0, 1. Enable equal to 1, 1, 0. Enable equal to 1, 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. When it is 0, 0, y0 equal to 1, 0, 1, y1 equal to 1, 1, 0, y2 equal to 1, 1, 1, y3 equal to 1. It is a bus line for bit 0. Example: we are reading and write operation of standard notation using specifying operations on memory transfer. Read operation and write operation and letter M. So we must specify the address of the memory word while writing the memory transfer operations. The address register is designed by AR and the data register is DR. Here it is a read operation M of AR and the memory of address register to data register. Here read operation. And what is a write operation means? I'm taking one register R1 with a particular data, and this data, what is address of this data? That is the AR. And what is the memory of this one? M of AR, R1 to M of AR. It is a write operation. It is a block diagram or symbol of this address register and data with a common bus system. And here address register is connected to the memory unit. The memory unit has read and write operation. What is a read? Data in means write, and read operation means it is a data out. Okay, like this. It is a block diagram or read and write operation. Here already the perform read and write to the standard notation of specifying operations. Okay, it is a read and write operation. Address register with the memory unit M with read and write operation with the data in and the data out. Okay, it is about the common bus system. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.